Hi, my name is Carly, and today we are going to be doing the Interactive Advanced Concept Presentation 7. So from week 3, we were asked to find a chemical in our home, and my chemical was glycolic acid. So today we are going to be going over Lewis structures, a little bit of molecular geometry and bonding between the glycolic acid. So I drew most of my structures out. So we'll start with our Lewis structure. So glycolic acid is C2H4O3. This has 30 electrons, and when we draw our Lewis structure, you can see here, when we count these up, we should have 30. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So moving on to a resonance structure, which a resonance structure, a term to good resonance structure should still have the same amount of electrons as the best Lewis structure does, and it still follows the octet rule that each atom cannot have more than 8 electrons. So what I did was took our double bond from our oxygen and made it a double bond with the carbon in a different spot. So we should count these up and we should still get 30 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So that would be a good possible resonance structure. Getting into individual polar bonds, I went ahead and listed the electronegativity for each atom here. So H is 2.2, oxygen is 3.4, carbon is 2.5. So here we can start to see the geometry coming in, and we still have our 30 electrons. Now, when you look at electronegativity and the individual polar bonds, the hydrogen will have a lower electronegativity than the oxygen does, so it is going to pull towards the oxygen. The oxygen is pulling it away, pulling the hydrogen closer to itself. So same with the carbon here. The carbon will be pulled towards the oxygen because it has lower electronegativity. However, the hydrogens that are bonded to the carbon also have a lower electronegativity, so they will be pulled to the carbon will then be pulled to the oxygen. We'll come back to the carbon-carbon one, but looking over on the right side of the diagram, the hydrogen will pull towards the oxygen similarly as seen over here, and the carbon will also pull towards the oxygen. Goes back to the same electronegativity. And this carbon is actually going to be getting pulled downward as well, since we have an oxygen below there, which has a lower electronegativity. Now, the carbon to carbon, they have the same electronegativity, so it will not be, there won't be a directional pull between the two of those. Now, in terms of dipole, the dipole for glycolic acid is uncertain. I did some research, and the Pitt quantum repository says that it is 1.85 plus or minus 1.08 dipole units. And I also saw where Blom and Bauder on Science Direct conducted Stark splitting of the glycolic acid, and they found a multitude of dipoles ranging, one of them was 1.913 dipole units, 0.995 dipole units, and 2.156 dipole units. So all of these are within similar range. However, the exact dipole is uncertain, and I have the links to these that I will put below. So moving on to electron geometry and molecular geometry. So these are going to be a little bit similar. We have our structure here, and I'm going to just break them down for you. So This HOC here, the hydrogen, oxygen, and carbon, these are for interior atoms, by the way. So there are a total of 4 domains. So there's 2 single bonds and 2 lone pairs. So when they have 2 lone pairs, then this is going to take on a bent shape. Moving on to oxygen, carbon, carbon, and the hydrogens. At the top, this will be tetrahedral, and it does not look like tetrahedral right now, but when I have my 3D structure, then you will be able to see the tetrahedral a little bit better. So there's 0 lone pairs and 4 domains. And moving on to carbon, carbon, oxygen, oxygen, there is a double bond and 2 single bonds. So there is there's 1 double bond and 2 single bonds. So there's 0 lone pairs, but there's only 3 domains. So this will be a trigonal planar. And then lastly, we have carbon, oxygen, hydrogen. And again, there's 4 domains and 2 lone pairs, so it will take on a bent shape. So I have my 3D shape here. And it's kind of hard to see, but hydrogen is black, oxygen is blue, and carbon is red. So here we have our bent shape. Our bent shape again, this is our trigonal planar, and then if I turn it, we have our tetrahedral here. It's kind of hard to see. So 1, 2, 3, and 4. This makes the pyramid, but it has 4 domains, so that is our tetrahedral. Now, talking about bonding that occurs between the molecules and within the molecule itself, we'll start with talking about what happens within the molecule. So mostly this is polar covalent bonding, except for the carbon to carbon, because they have the same electronegativity. This is still a covalent bond, but it is nonpolar. For bonding between molecules, this is termed hydrogen bonding. The hydrogen from one molecule is going to be attracted to oxygen of another. So you just see that I drew out the molecule twice, but these being close to one another, the hydrogen will be pulled towards the oxygen, and that is how the bonding will occur between 2 molecules of glycolic acid. So thank you so much for watching, and this was a fun project. I'm excited to watch everyone else's videos, and good luck.